Welcome, crew. In this section of this unit, we're going to learn how to use trig to solve triangles. These are our 6-1 notes on the law of cosines. What we already know. We really already know how to solve a right triangle. To solve a right triangle, or any triangle for that matter, means to find the measure of its sides and angles. So this is triangle, right, D, E, F, and to solve it means I want to find the measure of angle D, I want to find the measure of angle E, I want to find the measure of angle F, and I want to find the lengths of each of the sides of this triangle. So I want to find the length of side D, side E, and side F. Now, we're already told that the measure of angle F is 90 degrees, so I'm going to mark that with my box, and I know the measure of angle F is 90 degrees. We're told that side E, which is opposite angle E, is 7 units long, so we know that E is 7, and side D is 5 units long, right? Side D opposite angle D is 5 units long. So I'm left finding two angles and one side, side F. So let's start with the measure of angle D. If I want to find the measure of angle D, I know two parts of this right triangle from the perspective of angle D. I know the opposite side, and I know its adjacent side. Well, I'm pretty sure it's the tangent that use opposite and adjacent. So I can write that the tangent of angle D, which I don't know, is equal to its opposite side, which is 5, over its adjacent side, which is 7. To solve for D, we take the arctangent of both sides, and we get D is equal to the inverse tangent of 5/7 plus 180 degrees n. So I find the inverse tangent of 5/7, and I get that the measure of angle D is 35.538 degrees. Now we know that D is one of the acute angles of this right triangle. It has to be less than 90, so adding 180 is not going to give me an angle of a triangle. And I now know what the measure of angle D is. D is 35.538 degrees. So I'm left with finding E and F, right? An easy way for me to find the measure of angle E is that we know that the three angles of a triangle will add up to 180, right? Angle F is already 90, so we know that the measure of angle E will equal 90 minus the measure of angle D, which is 35.538 degrees. So I subtract, and I get 54.462 degrees. And I now know the measure of angle E. It's 54.462 degrees. All I'm left with is angle F, and since this triangle is a right triangle, we can use Pythagorean's theorem, which says that legs squared, so 7 squared plus legs squared, 5 squared will equal hypotenuse squared. F is the hypotenuse. Right? Solve for F by taking the square root of 7 squared, which is 49, plus 5 squared, which is 25, and we get F is the square root of 74. So 2 goes into 70, well, 2 goes into 74, 30 something. Anyway, we're not going to do that. Let's just do this. F is the square root of 74, or if we want to know about how big it is, we can evaluate that with the help of our calculator, and we get 8.602, right? One thing to think about is, does it make sense that the hypotenuse is longer than either of the two legs? Answer, of course, is yes. So we could solve the triangle this way, because we knew that triangle DEF was a right triangle. What if we need to solve an oblique triangle? Oblique means not right. So an oblique triangle, none of the angles are right triangles. Well, for that we need something new, and that something new is called the law of cosines. Now, I'm not going to go over the proof of the law of cosines with you right now. If you'd like to see that proof, let me know, and I'll make you a copy of it. It's rather lengthy, And I think for our purposes, we're just going to spend time using it. So let's move on here. And here is the law of cosines. So the law of cosine says that if we have a triangle, so I've got a triangle, and we'll make it so none of the angles are right. And I call this A, I call this B, and I call this C. So this is side A, side B, side C. It says that, I've got to change this. None of this should be here. So the law of cosine should just start with A squared. It says that any side squared will equal the sum of the other two sides squared minus twice the product of those two sides times the cosine of the angle that is opposite that side. So I've got A, B, and C here, but I think this is really better to learn in words. So let's just put that down. Right? So this law of cosine says that any side squared is equal to the sum of the squares of the other two sides minus two times the product of the other two sides and the cosine of the angle between those other two sides. Now, if we were to take this equation and we were to solve it for the cosine of A, we would subtract B squared and C squared, and then we would divide by this negative 2BC. And if we distribute that negative, we end up with this. We're actually not going to use that for anything, but if we take that and we remove the cosine by taking the inverse cosine, the arc cosine of both sides, then we have a formula for finding an angle when we know the three sides. So here's an example of using the law of cosines. So I have triangle PMF. I know M, the measure of angle M, which is marked. I know the length of side P and the length of side F. And our job is to find the measure of the third side, M. So I want to find M, and I know the lengths of the other two sides, and I know the measure of the angle opposite the side I'm trying to find. That's a perfect setup for using the law of cosines. So my law of cosines is going to say that the side I'm looking for squared, M squared, will equal the sum of the other two sides squared. So the sum of the squares of the other two sides. So we're going to take 8.54 and we're going to square that. That's a 4. Doesn't want to be a 4. And we're going to add 15.78 squared. Then we're going to subtract 2 times the product of those other two sides. So 2 times 8.54 and 15.78. And we're also going to multiply by the cosine of the angle opposite the side we're looking for. So that would be 127 degrees. So we can put all of this in our calculator, making sure our mode is in degrees, and we get that M squared must equal 484.1426. If we then take the square root of both sides, we get that M will equal plus or minus 22.0032. But in this case, because M is the side of a triangle, and those sides have never have negative lengths, that would be weird, then we know that the length of that side must be 22.032. And since these units are in feet, this would be in feet, and we could say that side M would be about 22.003 feet, right? In the spirit of this class, if we round, we're going to round to the third decimal place. All right, so that's one example. Let's look at another example. So here we have triangle XYZ. We're given the length of side X, side Y, and side Z. So we know three sides, and our job is to find the measure of the longest angle. So something you learned in geometry, the largest angle, excuse me. One thing you learned in geometry is the largest angle is always opposite the largest side. The largest side is side Z, so we know that we are looking for angle Z. So I want to find angle Z. So I'm going to use the form of the law of cosines that finds an angle. And that's going to be that this angle, angle Z, will be the inverse cosine of a fraction. What's going to go on the top of that fraction is the sum of the other two sides squared. So I'm going to take 3 and 7 and I'm going to square those and add them together. And then I'm going to subtract the square of the side opposite the angle I'm looking for. So I'm going to square Z, and then I'm going to divide by 2 times the product of those other sides. So 3 times 7. So I can evaluate that, and I get the inverse cosine, right? If I put all this in my calculator, keep in mind you need another set of parentheses if you put all that in your calculator. So you need parentheses to do the numerator, parentheses to do the denominator, or you won't get the right thing. So you should try that in your calculator and make sure you get negative 0.548. We take the inverse cosine, and again with triangles our mode should be degrees, and we get that Z is equal to 123.203 degrees, right? Or about 123.204 degrees. All right, one last example here. Suppose that the lengths of the sides in example 2 had been 3, 7, and 11. So if I take, and I recommend when you're solving triangles that you sketch one. So if this is X, this is, we'll do it the way it was. So this is X, this is Y, this is Z. Then this should be X is 3. And X is 3, Y is 7, and Z is 11 meters. Okay. And now we're trying to find the measure of angle Z. So let's do this again. And we get that Z will equal the inverse cosine, right, of a fraction. So in the numerator, we've got the sides that are adjacent to that angle. So that would be 3 squared plus 7 squared minus the square of the side opposite that angle. So that would be 11 squared. That goes in our numerator. In the denominator, we have 2 times the product of the first sides we use. So the sides adjacent to our angle. Right, we put all that in the inverse cosine, and the fraction ends up being negative 1.5. At this point, you should say, hey, there's a problem there. Cosine's never smaller than negative 1, never bigger than positive 1. And if you try to take the inverse cosine, it tells you that there's an error, which means this is not possible. And it's not possible because negative 1.5 is outside of the range of cosine. Okay, well, let's think back to what you learned in geometry. Right? So one of the things you learned is that the third side of a triangle, so I'm going to call that C, always has to be bigger than the absolute value of the difference of any two sides and smaller than the sum of those two sides. Right? Which means that if I have sides 3 and 7, right, 3 minus 7 is negative 4, its absolute value is 4, and if I take 3 plus 7, I get 10, which means the third side of this triangle would have to be between 4 and 10. So if that third side is 11, that's bigger than 4, but it's not bigger than 10, right, which geometrically, based on what you learned in geometry, also illustrates why, right, this can't happen. Okay, that's your law of cosines. Have fun using it. If you know your formula, all you're doing is plug things in. It should be easy squeezy.